I'm trying to get online, but I think the browser went somewhere. Just a second. Where did this go to? This is weird. Something happened to the computer. Like Chrome is gone for some reason.
Well, when you logged on, you are looking at my screen.
Yeah, but I have the app though.
Okay.
So that's, yeah, I'm just gonna sign into a
You're
different
on
one.
like your cell phone?
No, I'm not on my cell phone right now.
Okay.
I'm on my, I'm on the computer. But I don't know. The computer's being weird right now. It's not starting stuff up. Just give me a second.
Okay.
I'm trying to get it all worked out here. Uh, just a moment. Okay. Okay. I think I got it. I just want to do a different browser instead of Chrome.
Okay. Huh. Interesting. All right.
Signing in right now. Yeah, I don't know. That's a little weird.
Yeah, it is a little weird how different browsers work or don't work. It took me a while to discover that. Like Internet Explorer works differently than Chrome. Uh,
Yeah.
on my website, even. One reads it fully and the other doesn't read any of the GIFs that are animated. Um, so,
Yeah, that happened. I don't know why it's being weird like that. Okay, I'm logging into some of the stuff right now.
yeah.
Just trying to figure out what we got going here. Hmm. Okay. So, yeah, here's this one right here. It's just taking forever to load. Alrighty. So this one right here I have. Are you ready?
What's that?
Are you ready for the first question?
Go ahead.
It says a rhombus is inscribed in a rectangle that is W meters wide with a perimeter of 44 meters.
Hold on 1 second.
Yeah. Okay. Let me know when you're ready.
And a rhombus is inscribed.
Yep.
Well, that means the rhombus must be like that.
Yeah, pretty much.
Okay, go ahead.
And then it says the vertex of the rhombus is a midpoint of each side of the rectangle. Express the area of the rhombus as a function of the rectangle's width.
All right. Well, I didn't draw it right then.
No, it's like the rhombus goes to touches every corner.
Right. For some reason, you mean the midpoint. That's each vertex is there. Okay, I guess that still creates 4 equal sides, doesn't it? For some reason, I
Yep.
was thinking you wouldn't have a rhombus if you did that, but you do. Rhombus being 4 equal sides. Okay,
Mm-hmm.
so this is W, and the perimeter is 44. Is that all we know?
Yep.
And what's the question? Is what?
Each vertex's rhombus is a midpoint of the side of the rectangle. Express the area of the rhombus as a function of the rectangle's width.
Okay. So we want the area as a function of W.
Uh,
Okay. Well, let's call that X, which means all of these are X. Definition of a rhombus. And we know the perimeter is 44, therefore X equal what?
so isn't that a 90-degree angle, right? That's
No, don't worry about angles yet. Just
Okay.
what's x? If the perimeter of this rhombus is 44 and you're dealing with 4 equal sides, what's each side equal to?
Could you divide it by 4 or no? Does that not work that way?
Yeah, no, it does. In other
So
words,
it's 11 then.
the perimeter is merely the sum of each side.
Oh,
So now we know that that's 11.
okay.
Mm, so let me think for a second here.
But we need to know
Well,
the volume
that's
anyway.
half W. We don't know what that is. We don't know what that is at the moment.
Okay, so the top part is 1/2 W.
Well, hold on. No, that's just the measurement of that side of the triangle because we know the whole width is W. Would you read the problem all from scratch again, just so
Yeah,
make sure I'm not missing some information here?
for sure. A rhombus is inscribed in a rectangle that is W meters wide with a perimeter of 44. Each
Hold on a second. The perimeter of the rectangle is 44.
a rhombus is inscribed in a rectangle that is W meters wide with a perimeter of 44.
Ah, okay. Well, I got that wrong then. Here, let's go back and redraw our picture here. Yeah, that I think might make the difference. Okay, there's our rectangle that's W wide. There's our midpoints. So here's our rhombus. And let's call this the height.
Okay.
Because what we know is that the perimeter is 44. So 44 equals 2h plus 2w.
44 equals 2h plus W.
Plus 2w.
Mm,
Remember,
okay.
the perimeter, that's w up there and that's h over there. So the perimeter is the sum of the four sides.
Okay.
And that's what they're telling us is equal to 44. They're also telling us that this is the midpoint. So from there to there is 1/2 h, and from there to there is 1/2 w. Now, the area of the entire rectangle is HW, and the area of the rhombus is going to be the area of the entire rectangle minus the four,
The four corners.
well, minus the four triangles, yeah. And actually, I know that the area of the rhombus is half. Okay, now I got it. The area of the rhombus is 1/2 the area of the rectangle. For the same reason that if I put two triangles in any, when I do that, the area of that triangle is 1/2 the area of the rectangle. That's why the area of the triangle is 1/2 the base times the height. Okay? So
Okay.
if I wanted to, I could draw a dotted line there and a dotted line there. And now I have four rectangles and I've got a triangle in each one. So each triangle, that little triangle there is 1/2 of that little rectangle. Therefore, I know for sure that the area of the entire rhombus is half of the area of the entire rectangle.
Okay.
Okay? Well, what that means is that the area of the rhombus is 1/2 HW, merely substituting. And they want the area of the rhombus to be a function of W only. Well, right now I have it as a function of H and W. But if I go up to this line right here, I can solve H in terms of W. So the first thing I'm going to do is divide both sides by 2. So that gives me that. H is equal to 22 minus W. So now I go into this formula here, and wherever I see H, I substitute 22 minus W, now times W, and there you go. A as a function of W. Now I can simplify that a little bit. That is 11W minus W squared over 2.
Okay.
There's a good answer. This would also be a satisfactory answer. The one that's right to the left of that equal sign.
Let me try to enter that real quick.
Oh, that's right. You got to enter it and you'll get to see whether it's right or not, huh? Now, the question is, well, how are they going to want that answer? I would enter the one on the right.
Okay.
Yeah, they like that.
Let me see. It says, ooh, hold on, I typed it wrong. It says that's not correct.
Okay, try entering it as this.
That one? Okay.
They're the same thing, I believe, unless I did a math error wrong.
That's right. So it's 1/2. 1/2 parentheses 22 minus W. That's correct.
Oh, really? So they like this answer and they didn't like this?
Yeah, I guess so.
Amazing.
It's a little weird, but whatever.
Definitely some simplification. If nothing else, I divided 22 by 2 and got 11. So this has a little simplification to it. I can't believe they didn't accept it. That's what's terrible about those programs. Is the fact
I want to get off the volume questions because, like, I kind of know how to do volume on my own, so I can do that one by myself.
Whatever you want to do, you call it.
I don't know. I didn't realize that those are volume, so I'm just trying to figure out.
That's not a volume question.
Oh, well, not fully,
That's
but
an area. It's a geometry question.
yeah.
And that is different. You haven't been doing a lot of geometry with me. You've been doing mainly algebra 3.
Okay. I'm looking on this one now. All right. So here's one. It says, given that f of x equals x minus 1 and g of x equals x squared minus x, then find f parentheses f plus g parentheses 4 if it exists. Df
F
in the
plus G of 4, like that?
Yeah.
Like that, maybe?
Yep.
How do they write it in the book?
They'd say parentheses f plus g, and then they have another parentheses for the 4, like that. Yeah.
Just like I've written it. Okay.
Yes.
What they're telling you to do is, by this step, add the two functions together and then evaluate it, what you get at 4. And whenever you're evaluating something, you merely plug in whatever you have in the parentheses in for whatever x's you have. So first add the two functions. What do you get?
Add the two functions.
Yeah, what's that plus that?
Well, which you just get f plus g.
No, add the two functions and in terms of the polynomials. That's what f is. That's what g is. Add those two together.
Okay. Where would those plug in?
Hold on. Let's add them together first. Here's how you add them together. I got that over there, and I'm adding that. Okay?
Okay.
That's
So
how
would
you
you get,
essentially add them together. What do I have?
would
X
you get x
squared
squared?
minus 1. The x's go away. I got a minus x and a plus x.
Okay.
Okay? So f plus g is this. That is f plus g. Now, if somebody says, what is f plus g of 4? What are you going to do?
You're gonna plug in the 4 for the x.
Go ahead.
So we'd get f plus g equals 4 squared, which is 16, minus 1, which is 15.
That's it.
F plus g equals 15. Okay.
f
Plug
plus
that
g of 4.
of 4, yeah.
F plus g equals x squared minus 1.
Okay.
But evaluated at 4, it's equal to.
Okay, so the next one we have is f of x equals 2 x squared. Sorry, it's just x squared. X squared minus 5. And g of x equals negative 7x plus 4. And then it says find f of g, or f over g, and 4 over 7 if it exists.
F of 4 divided by g of 7?
We have f over g, and then it says multiplied by 4 over 7.
That doesn't mean multiplication, first of all.
Well, it's just parentheses.
In other words, when you write f of x, that's not f times x. It's f of x.
F of, yeah.
To designate the difference between multiplication, you need to use the word of. So the way I would verbalize this is, what is f divided by g of 4/7?
Okay.
Okay. Now the first thing we have to do is divide f by g.
Divide f by g.
Well, yeah, because that's what it's telling us to do, right? F over g.
So we get x squared
Well,
minus
I
5,
don't
or
really need to do this with long division. I can do it just like this.
yeah.
But you're going to see where there's a problem.
Okay.
What is that problem going to be?
It doesn't really divide because there's no.
No, it might divide. But that's not the problem. The problem is that what is the denominator when we substitute 4/7 for x? Forget the numerator for a moment. Solve the denominator.
Well, the x squared kind of screws things up.
Don't look at that. Just look at the denominator. The bottom part.
And there's a negative.
Substitute 4/7 for x. What do you get in the denominator after you do that?
Well, you would have a negative, right?
No.
That.
Here's what you get. I'm going to substitute 4/7 for x. That thing is now equal to 0. I get minus 4 plus 4. That goes to 0, and you cannot divide by 0. So I don't care what the numerator is. I got problems. The moment I am dividing by 0, that means there is a domain restriction on this. In other words, that is undefined.
Undefined.
Mhm.
Okay.
Whenever you're dividing by 0, your answer is essentially undefined because
Okay.
you can't do it. In other words, if I look at each one of these functions individually, x is not restricted. X can be all real numbers in the f function, and x can be all real numbers in the g function. But the moment I divide f by g, well, now all of a sudden I'm saying that no, it can be all real numbers except for 4/7. So when you try to define it as 4/7, you end up getting 4/7 squared minus 5 all divided by 0. So whenever you're dividing by 0, that's undefined.
Okay, that makes sense.
Is that one of your options?
Yeah, that's it.
Okay, good. I was going to say, I'm not sure how you, because there's undefined, does not exist, various infinity, there's various terminology that all kind of mean the same thing. But
All right. So what we have now is f of x equals x squared minus 10, and g of x equals 6x minus or plus 1. And it says find fg of negative 1/6 if it exists.
F dot G maybe,
No, it's just parentheses fg. Yeah, that's more like it.
but they're meaning multiplication.
Yeah, yeah, yeah.
Of what number?
Negative 1/6.
Okay. Again, this is not multiplication here. They're multiplying
No,
the two
yeah.
functions, but once they multiply them together, then they're going to evaluate it at minus 1/6. Okay? Now,
Mm-hmm.
if I'm going to multiply the two together, this is what I'm going to do. Okay? Now, I
Okay.
could go to the trouble of foiling those, come up with an answer, and substitute negative 1/6 and figuring out what I got. But there's actually a shortcut that tells you what your answer is going to be real easy, and that is if you plug in B4. Just like the previous problem, we didn't do that division. We went ahead and plugged in the 4/7. In other words, we wrote it as what they're saying, and then we're going to plug in negative 1/6. Well, nothing special happens with this term, but a lot special happens when you plug in minus 1/6 into that term. What happens? What does that term go to?
Does the 6 get taken away?
What does that term go to when I plug in minus 1/6 for x?
That just goes to, does it double? Because it's
You
multiplying.
guessing.
No,
Why are you
it goes,
guessing? Here's what we're doing. There's our function. We're plugging in 1/6, negative 1/6 for x, and we're solving this. What is that?
it's 0.
Okay.
It's 1.
So the fact that that is 0, again, we don't care what x squared minus 10 is. When you multiply anything by 0, you get 0. So
Okay.
by doing the shortcut, we were actually able to eliminate 5 minutes worth of multiplication or 2 minutes worth of multiplication. We didn't need to actually multiply these two things together. We just need to notice that one of them was 0. And if one of them is 0, that answers the question, just like it did in the previous problem when they were doing division. The moment we discovered the denominator was 0, we were done. We didn't really have to do the numerator. Same thing here. The moment we see that this part is 0, we're done. We don't care what this is over here. When you multiply whatever this number is by 0, you get 0.
Okay, so it's undefined then?
No, it's 0. It's not undefined.
No.
0 is not undefined. Make sure you notice the difference. If I
Okay.
take 0 divided by 3, that's 0. You can have a 0 in the numerator, But if I take 3 and divide it by 0, that is undefined. You just
Alrighty.
cannot divide by 0. You can divide into 0. And if you have 0 divided by 0, that's called indeterminate. That's an indeterminable. Okay?
Okay.
Indeterminable.
Alright. So the next one I have is h of x equals x plus 2 and g of x equals the square root of x minus 5.
Like that?
Yep.
Okay. Now, notice in this case there are some domain in both of the 3 previous problems we've had. There's been no domain restrictions in the 2 original functions. And yet one of them, when you divided them, we picked up a domain restriction. So when you act on these functions, you can change the domain. Well, with this problem, we don't have any domain restrictions on the h function. That's all real numbers. But we do on the g function. What's inside the radical has to be greater than or equal to 0, which means x has to be greater than or equal to 0.
Okay.
So that is the domain restriction for the g of x. Now what are they asking for?
They're asking for h minus g of 4.
Does not exist.
Does not exist?
Or undefined.
Yeah, okay.
See why? Again, we don't have to actually do the subtraction. I could write it, but why? Because I can't plug in 4 for x. My domain restriction is x has to be greater than or equal to 5. So there's no way I can plug in 4.
Why is it greater than or equal to 5? Because
here's what you do. When you have a radical sign, you take whatever is inside the radical sign, which has to be greater than or equal to 0. You can only take the square root of 0 or positive numbers. So that's what makes that true. And then if I just solve that, I get that. So I know that I'm not going to be able to plug in 4 into the g function. So regardless of what they're doing, doesn't matter.
that makes sense.
I'm restricted to my domain restrictions of the original functions, always. Sometimes you'll pick up additional ones. For example, if they wanted to know what h of x divided by g of x is, well, now I've picked up an additional restriction. Not only does x have to be greater than or equal to 5, it's got to be greater than. Because if x were precisely equal to 5, well, now I'm dividing by 0. So this is more restrictive than the original function. And it's more restrictive because in the process of dividing by g of x, now there's more restrictions. You can't divide by 0.
Okay.
Okay. I don't know what their choices were. Hopefully undefined was one of them.
Yeah.
Okay.
So the next one, it says the functions of f and g are defined as f of x equals 4x plus 3 and g of x equals 7 minus 6x. And then for part A, it says find the domain of f comma g comma f plus g, f minus g, fg, f dot g, and then f over g,
Hold on.
and g of
Let
f.
me make sure I keep up here. So we got the original functions, the sum, the difference, multiplication. Surely f over g is one of them.
Yeah. FF is one too.
F times F is another one. What else?
Yeah,
You get them all?
and G over F.
G over F. Okay.
Mm-hmm.
What's the domain restrictions of f of x? In other words, yeah, we're going to answer just the f part. We're going to work our way from left to right.
So from left to right.
What is the domain of f of x? Is what my question is.
What are the domain restrictions? I need your help on that.
Domain means all values of x that you can plug in if you want to.
Okay.
So the way to think about domain is what you cannot plug in. In other words, all of these domain restrictions that we've worked on in the last 4 problems, you couldn't divide by 0, you can't take the square root of a negative number. All of those are domain restrictions. Okay? So that's usually where you have them. You don't have domain restrictions with f of x. I can plug in 0, I can plug in negative a billion, I can plug in positive a billion, I can plug in all plus or minus numbers, fractions included. So the domain restrictions on f of x is all real numbers. Let me just write that above it like that. Okay?
Is that the same for G of x?
Same for G of x. There's nothing that would prevent me from being able to do this. You cannot divide by 0, but there's no division going on here and there's no square root going on. So usually you need special considerations to have a domain restriction. And it's always best to look for that. Don't try to figure out what x can be. Try to figure out what x cannot be. Okay, what about f plus g?
F plus G? There's all real numbers on that too, right?
Okay, yep. In other words, that's just going to give me some number of x plus a number. In other words, it doesn't cause division or anything to happen. Okay, how about f minus g?
Same there, right?
Uh-huh.
And the multiplication.
Times g.
That works too with all real numbers.
All real. In other words, I'm going to end up with a quadratic. I might end up, I don't want to waste space here, but you can see what I'm going to end up with, minus 24x squared, and then I got 18, I got 28 plus 10x plus 21. So that's what I get when I multiply them together. Well, again, when you have a polynomial like that, there's no domain restrictions. I'm not dividing by the variable, and I'm not taking the square root of any variable.
Okay.
So all reals. Now we're getting into the ones that might have domain restrictions. For example, f divided by g.
You just can't have 0, right? As a denominator.
Here's what we get. Now tell me, what values of x make that undefined?
What values of x make that undefined? You can't have a 0, right?
Be more specific in terms of your answer.
X can't be 0.
No,
Or
x can be 0. If I let x be 0, then my denominator is 7.
well, x can't be
So
0, but
it's not x that can't be 0. Your
just the denominator.
never be 0. So set up an inequality and solve it. 7 minus 6x. We'll solve it as an equality, and now we'll be able to solve it. If you solve that, you get x of 7/6. In other words, it's an x of 7/6 that you cannot do. So I'm going to write on this one, all reals except x cannot be the number 7/6. Because if I substitute 7/6 for x, then the denominator is going to be 0.
Okay.
Okay? So f times f.
That's all real numbers too, right? Or no?
Yeah, it's basically the same as f times g. In other words, you don't result in division, you don't result in square roots or anything like that. And then the last one, g divided by x. Well, let's write this one. 7 minus 6x divided by 4x plus 3. What can x not be?
Well, the denominator can't be 0,
Okay,
so
spell out each row for me. Tell me what I should write next.
would you do 4x plus 3?
That's the denominator.
Yeah. And then would you
And you can do this
would
one of two ways. You can make it equal to 0 and just solve, and that's the answer as to what x can't be. In other words, our answer is going to be all reals except whatever this comes out to be. So what does x come out to be here?
so x would come out to be would you subtract the 3
Uh-huh.
on the other side and then divide by 4, so it would be 3 over 4.
Negative 3/4.
Yeah.
So all real numbers except x cannot be negative 3/4. So there's your 8 domains. Now, when I wrote this the way I did down here, another way of doing that is just say it can't be. When you draw a line through the equation, that means you're saying 4x plus 3 cannot be equal to 0. You solve it the same way, but your answer comes out to be x cannot be equal to minus 3/4. And over here,
Okay.
x cannot be equal to 7/6.
Alrighty. So, what would the domain of f is real numbers, right?
I've written
So
the
could I just
domain above all of these.
okay, so is that just infinity then? Would that be an answer? Or
What are your choices?
it doesn't give me a choice. It says the domain of f is blank.
What kind of, there's always all kinds of ways to represent domain. There's
Okay.
interval notation. It's probably what they're going to want. I would think any computer program is going to want the answer in interval notation.
Yeah.
Okay, here's what interval notation is. Negative infinity to positive infinity. You'd have to write it exactly like that.
Okay.
Make sure that it accepts that, and then we'll go through each one.
Would it be hold on. Oops.
In other words, starting from the left end of the number line, negative infinity, and you're going to the right end of the number line, positive infinity. That's the same as all real numbers. That's what all real numbers means. That right there.
Okay. It's the domain of f plus g.
Same thing.
That's all real numbers too. Yeah. Okay.
Same thing. All 5 of these are going to be negative infinity to positive infinity.
Okay.
Now, when you use interval notation on the next one, it has to be done in intervals. Okay? So the left interval is negative infinity to 7/6 with a parentheses, because it cannot be 7/6, in union with 7/6 to positive infinity. And notice that interval notation means all real numbers except for 7/6.
Alrighty. So the answer, yeah. Alright, I'm still writing stuff in. Give me a second.
That's okay.
This is you have to like type all the infinities in, which is kind of weird. But so then
Usually they give you a toolbox that has the
they
infinity
do.
signs and the union and union with and stuff like that.
So then for f of g, it's x, and then what's that equal sign mean when it has the line through it? How do you verbalize that?
Which one are you doing? If we're going to use interval notation, you want to use interval notation for all 7 answers.
What's
You're not going to
for
use
f of
this
g?
notation over here. That notation means the same as interval notation, but if you want the interval notation for that answer, it's minus infinity to minus 3/4 in union with minus 3/4 to positive infinity. In other words, exactly the same as the other one. You go up to the number that it cannot be, and then you start another interval starting at that same number. And the fact that I'm using parentheses here means that it cannot be 7/6 in that case, and it cannot be minus 3/4 in this case. So this is the way you write the domain in interval notation. Like I said, there's 3 or 4 ways to write domain. I don't know what your computer program wants. If interval notation is the most consistent and accurate and works every time, it should. Whether you have
Okay.
to use it or not, I don't know. You might get away with doing it like I've done it there. All real numbers except for x cannot be equal to 7/6. That's one designation. That's one way you can express domain. But the more common way is interval notation.
All right. What's f over g for that one? So would that be the union thing?
This one here. That's f over g, and the one below it is g over f.
All right. Okay. Let's see.
All the others are negative infinity to positive infinity.
All right. I'm writing that down right now. Let's see if it's correct. And we'll see in a minute here. Oops, that didn't work. I think that one worked. Hold on. I think I typed it wrong.
Can you tell each one, or do you have to put in all 7 of them or all 8 of them and wait and see if you get the right answer? Does it tell you after you put, in other words, did you try putting in f as minus infinity to plus infinity, and did that work?
Yeah, that worked.
Okay. So where's the first spot where it didn't work? F over G?
Yeah, I typed it exactly how it said, though I think it was just a glitch in the computer system because I typed it the exact way it said and it just didn't work.
The way it said or the way I've written it?
No, the way it said. Like I typed it the exact way it said and it like didn't work.
Not quite sure what you mean, what it said.
No, like I entered it and it said it was wrong,
Uh-huh.
and then I looked at it and it said that it said gave me the right answer. The right answer was the exact thing I put in. So that's why like I'm confused.
I'm confused also. Sometimes it's very difficult to understand. You mind if I make you the presenter? Maybe I can see what it's doing?
No, it's over now, but
All right.
it was just that was dumb is all it was. Because like you know how the answer, like if you don't type it in correct, it gives you the correct answer. And the answer I typed in
Oh, so it
was,
told you the correct answer, which was what we were trying to type in.
and then it
Thought you
said,
typed in, but then it said it
yeah,
was the wrong answer. Well, maybe you
yeah,
just did something, maybe you didn't use the right infinity sign or the right union. In other words, this is the first one where you're having to use this in union with. You
but I
don't
did the second
don't
one the
want to
same
type
way and it
a
was
U there.
right.
You want to get that from their toolbox. You don't want to
Yeah, I
type
did.
a U.
I did get the U from the toolbox.
Okay. And it still said
Yeah,
the wrong answer.
it was. I think that was a glitch because it gave me the wrong answer for no reason.
It gave you the answer that I have on the page here.
Yeah, and the answer I entered.
Okay, but it said it was the wrong answer. Most
Hmm.
likely you're going to run into the same thing when you do G over F.
I actually got that one right. That's why I'm confused.
Really? Wow, that is strange. Okay.
Yeah, that was. I think that was just a dumb little computer glitch.
Okay, what do we got next?
Hold on, I'm writing it down now. Okay, let me go to the next one. So it says the functions of f and g are defined as f of x and x plus minus 5. G of x equals the square root of x plus 9.
Notice the domain restriction on G of X.
Yeah.
What is it? Tell me how you figure it out.
So the domain restrictions are, this one is the same, right? It's infinity, like because of,
Well,
hold on,
just
let me
figure
look
out
that
what
up.
it is first. How do you figure out what the domain restriction on G of X is?
Everything it can't be.
Yeah.
Okay, so
What
f
does it
is
have
just,
to be? That, in other words, there's a technique here you always want to use whenever you see a radical sign, is take whatever is in the radical sign, in this case x plus 9, and say that it has to be greater than or equal to 0, and then just solve it. And that tells you what the domain is. That means x has to be greater than or equal to minus 9. So that's our domain, one way of expressing it, for g of x. Now, what is the question on this one?
it's the same type of thing.
Okay,
Hold on.
let's do them one at a
That,
time.
so f, oh yeah, okay. And these are all different. Okay, so the only ones that matter are f over g and g over f.
Correct. Well, not really. G of x matters also, because the function g of x does have domain restrictions. X has to be greater than or equal to minus 9.
And the multiplied one,
Same.
the multiplication.
In other words,
Yeah.
multiplication results in this. X minus 5 in parentheses times square root of x plus 9. Well, I can't actually do that multiplication, and the domain restriction is still the same. In other words, x still has to be greater than minus 9. However, it does change a little bit when you get f divided by g. In other words, if I have x minus 5 divided by square root of x plus 9, that is different because now what's inside the radical doesn't have to be greater than or equal to 0. It has to be greater than 0. So here, x plus 9, because I can't have this ending up being 0, then I would be dividing by 0 also. So I take what's inside the radical and make it greater than 0. Has to be greater than 0. It's not this domain restriction up here. That's greater than or equal to minus 9. This is going to be greater than minus 9. So when you have f divided by g, the domain restriction is that right there. Now, if written in interval notation, how would I write that?
Interval notation.
Isn't that what you have to give the answer in?
Yeah. Would you just have to say the? I'm not sure. Like, would it
Minus
have to be greater than 9?
minus 9 to infinity. Start on the left side of your number line. Well, since I've got to be greater than minus 9, then there's no number to the left of minus 9 that it can be. And this is the way I would write the interval notation for that one. This one up here, the domain of G itself, I'm going to write different. I'm going to write it with a bracket, minus 9, comma, infinity. And here illustrates the difference between a bracket and a parentheses. In the one on the far right, the bracket means that it can be minus 9. Has to be greater than or equal to minus 9. Okay? The one
Okay.
on the left says it got to be between minus 9 and infinity, but it can't be minus 9. It's got to be greater than minus 9. And so that's why I use a parentheses here and a bracket there, because they're different. One is a greater than or equal, the other is just a greater than.
Okay.
Okay? And then the other only difficult one is going to be G divided by F, and that's going to be square root of x plus 9 all over x minus 5. That's got some, here, let me scroll down. Yeah, we got just enough time to do this one. Square root of x plus 9 all over x minus 5, correct?
Mm-hmm.
Well, this has got a couple of domain restrictions. Let's look at the numerator first. Tell me what x can be with looking at just the numerator.
Just the numerator? Well, it has to be, so does that have to be greater than 9?
Greater than or equal.
Okay.
Got to be greater than or equal. I don't care if the numerator, and it's minus 9, not 9. Notice that if x is equal to minus 9, the numerator is 0. Notice that if x is equal to minus 8, the numerator is a positive number. So anything greater than or equal to minus 9 is fine for the numerator. But I also have, and if I want to write that in interval notation, I'm going to write it like this. Minus 9, brackets, comma, infinity. Infinities always have parentheses because it can never be exactly infinity. It's not a number, it's a concept. I also get a restriction on the denominator. What can x not be in the denominator?
0, or is it 5? Is it x is greater than or equal? No, that wouldn't work that time.
X can be all real numbers except 5. That's what's
All real numbers except 5?
yeah.
Okay.
In other words, there's nothing that keeps x, well, we're talking about just the denominator now. We're going to talk about the combination of the division, because that's going to give us a domain that is we're going to require interval notation. Is all I've done here. I'm going to list the interval notation of both the numerator and the denominator separately in union with 5 to infinity. Okay, so this one is the domain of the numerator. This one is the domain of the denominator. So the goal is to write all of that as one interval notation.
Okay.
Well, to do it, start from the left side. Minus infinity. Can't have minus infinity. We can only go down to minus 9. So the lowest number that I can possibly have is minus 9. And I can have that. So I'm going to use brackets. There's minus 9 doesn't hurt anything here. It doesn't make the function blow up. However, it's not to infinity because I know it can't be equal to 5 either. So it's that. In other words, it can be anything from -9 to 5 in union with 5 to infinity. So that is what the domain of the one divided by the other is. That's F over G. Or G over F, whichever it was. I didn't write it down. But make sure you understand how I put these two domains together.
Okay.
Okay? In other words, that on a number line is from -9 to infinity. Just call it. In other words, if I draw a number line, here's -9. That's the allowable x's for the f function. For the top.
Alrighty.
The bottom one is every point on that number line except 5. So if I want to combine the two, then I've got to go from -9 to 5 in union with 5 to infinity. And I do need a bracket next to my -9. I can still be -9. When we reverse these and we do G divided by F, well then X isn't going to be able to be -9 anymore, because that's going to make that whole thing 0 in the denominator. So let's see, what are we doing here? We got another session. We're going to take an hour break and come back.
Yeah.
Okay. Sounds good. I'll talk to you in an hour, Merrick.
All right. Thank you.
You're welcome.